All right, inverse of functions. So when we're doing inverses of functions, functions are just graphs that have specific qualities, which we'll discuss. I guess if you have any questions, we'll discuss it tomorrow in class. But when we're finding the inverse of functions, you have to do, well, let's recall. Solve for x. Right? To solve for x, you need to get everything away from x. So you need to do the inverse operations of each value. So if I have a negative 6 here, in order to move that to the other side, I need to add 6 to both sides. That's the inverse operation for subtraction. The inverse operation for subtraction is addition. And this is 2 times x, so in order to remove the 2 from the x, I need to do the inverse operation to get rid of it. So that's when I'm talking about inverses. This is, in the most basic sense, what I'm talking about. The operation that lets you undo the other. And that's very similar to what we're going to be doing when we're talking about inverses of functions. We're just going to be dealing with their equations and what's the inverse. So again, what does inverse mean? Well, the two that you should be somewhat familiar with is the additive inverse and the multiplicative inverse. Okay, the additive inverse is two terms, or they're inverses of each other. It's two terms that add to 0. To 0. And remember, 0 is the identity element. Identity. Okay, identity of 0. So you add, remember 1 plus 0 is 1. It keeps its identity. It doesn't change when you add it to it. So the additive inverse is like 2 plus what would give me 0? Well, that would be negative 2. Okay, so 2 and negative 2 are additive inverses. That's the basic idea behind an inverse. Multiplicative inverse is two terms multiply to 1, because 1 is the identity in multiplication. Anything times 1 stays itself. So 5 times what would give me 1? Well, that would be 1/5. That's the additive inverse. So all of these things are all related to each other. They're all talking and they're all leading up to the inverse of functions. So the inverse of a function, it's more complicated, obviously, than the additive and the multiplicative because functions can be very complex. They can be crazy graphs, Okay, so doing a inverse of them can be a bit more complex. So we have a process to follow. So inverses of functions is simply a reflection through the line y equals x. That's the inverse of a function. In the most basic sense, that means that x and y are switched. And then crazy wonderful things happen, and you'll see why I kind of discussed the multiplicative inverse and the additive inverse. It's all surrounding them, and it's all a part of it. Inverse is very all-inclusive. So the notation for the inverse of a function is that -1 power. It's f to the -1. It does not mean to the -1 power when it's on a function like that. It means the inverse of f of x. Okay, to do this, we have to remember the inverse of all of these wonderful operations. So what is the inverse of addition? We just talked about that. It's subtraction. Oh, that says subtraction. The inverse of subtraction is addition. The inverse of multiplication is division. You just have to think about what do you do when you're solving an equation. What's the inverse of division? It's multiplication. Hopefully that wasn't really nothing new. So what's the inverse of squaring? So what I'm saying is if we have x squared equals 9, how do I figure out what 9 is? Well, you take the square root. Okay, square root. And there's millions and millions of others, and we're going to be doing a lot of different inverses, but this is just the beginning. Square rooting, the inverse is squaring. So when we have x, they're inverses of each other, just like all the rest were. So x squared equals 9, I take the square root, I get x equals plus or minus 3. So x could be, it could be negative 3 squared equals 9, or positive 3 squared equals 9. Both of those work. Both of those are that particular answer. All right, so let's just do some basic examples. Hopefully you're a little confused so that your brain is working. But I do have some steps you can follow to kind of follow along until you start to understand it a little better. These are the steps. They're down at the bottom. I'm going to follow them as we go. So the first thing we do is we generally eliminate the f of x and make it y. For no other reason than it is just easier to deal with y than f of x when you're solving an equation. Right? Then, to reflect it, to find the inverse, we have to switch our x and our y, reflected through the line y equals x. Okay, technically that's the inverse now. We could be done, but since we wanted to find f inverse of x, we do have to solve. And we have to make sure the inverse is by itself, so we have to solve for the y. So x plus 3. So notice what's happening here. So I'm simply just solving the equation, but I'm solving it for y. So can't really do a lot of math. So x plus 3 can't be added, dividing by 2. I'm just doing the inverse operations. So you can see up here, technically this is the inverse. We're going to write it a little better than that. If you look up here, 2 is multiplying times x, and here 2 is dividing. Here 3 is subtracting, here 3 is adding. Notice how the inverse operations play a part in finding the inverse of functions. It's really cool. So the last thing we have to do is we have to write this because we want to solve for the inverse of f of x, not y. We want to solve and rewrite it. Now, please realize that you can also divide and rewrite this one as, sorry, that's my phone. Okay, so here, these two are equivalent answers, both totally acceptable, but realize that that 2 is divided into both pieces, so 2 divided into x, and the 3 will leave you with this as your inverse. Both acceptable, both beautiful, love them both. So all we're going to do is a few more examples here. Place y here. Okay, so, sorry. I forgot to switch x and y. I was solving right away. So switch x and y. So x equals y minus 3 over 4. I like to cross multiply here. You can multiply both sides by 4. It's the same thing. So it's 4x equals y minus 3. This one is a beautiful problem. So it's 4x plus 3 equals y. So I'm just solving each of the equations for y. You know how to solve an equation. And you just have to make sure that you just combine your like terms when appropriate. And right here there haven't been. So 4x plus 3, that is your inverse. All right, we got a squared on this one, but the process is still the same. Replace it with y, switch x and y. Just remember, when you're switching, you only switch the letters. All the other numbers stay in exactly where they are. So I want to get y by itself, so I'm going to add 3. Get rid of everything but the y, right? So take a second and look. This is where the y is. I want to get rid of this -3. I want to get rid of the 2. So let's do it. So we add 3. That gets rid of the 3. And since I can't add these together, I'll just leave it as x plus 3. Then I have y squared, and to get rid of squared, I do the square root. So y equals, when you take the square roots to solve a problem, you have to have the plus and minus of that function. So it would be the inverse of x is equal to plus or minus the square root of x plus 3. Beautiful. And finally here we have square root. We're going to have a whole section on solving radical equations, but if you can do this one, it'll make that one a little bit easier to remember. Switch the x and the y. Now it's a radical, which is another name for a square root. To get rid of a square root, all that 4y minus 7 is underneath the radical. So I got to get rid of it before I can do anything. So I'm going to square both sides to get rid of it. Now it's like the 4y minus 7 is free. Now I can break those little pieces apart, so I will. I'll add 7. And divide by 4. So just like the last time, the inverse is x squared plus 7 all over 4. But you could also divide that 4 into both of those pieces and write it, instead of one term, write it as 2 terms. So it'd be x squared over 4 plus 7 over 4. All right, we love math. Have a great day.